Hello everyone. Welcome to today's Leetcode Live. Let's dive straight into it. Okay. Now, minimum operations to exceed threshold values too. Okay. Problem number 3066. You are given a zero index integer array nums and an integer k. Okay. So you are given nums and k. In one operation, you will take two smallest numbers. So one and two. Let's take that. And smallest integers x and y, and remove x and y from one. Okay, two and one are removed. Add this thing into the array. Okay, and um, okay, only this operation we can do, and if there are only two numbers, we can do this operation. Okay, um, return the minimum number of operations needed so that all elements of the array are greater than or equal to k. So we have to find out the number of operations that we can do. So for that, I think we can just do the operations. That will be the best way to tackle this problem. So how do we get the minimum two bits of this? And we want it regularly. So I think we can use a min heap for that. We add these numbers to a min heap, we get the min two values, and we append this some anywhere, we just add that back. Um, we then get another minimum two numbers and do that until and unless all the numbers are greater than k, or can we get a negative answer? So answer always exists. That there exists some sequence of operation where okay, so answer always exists, so we don't have to care about if the number go less than two, the size of the lumps goes less than two. So I think this is the best solution we can go for is just follow this sequence in a while loop and find the number of operations. So what time would it take? It would be an O of n square operation because n square log n. Uh, okay, so we put all these numbers into a main heap and we remove the smallest two and we add back. So let's say, so it should take the time complexity is a little difficult to think for me right now. Let's see, let's write the code and let's see the time complexity then. So let's go for that. So priority we int comma vector int comma greater int pq for auto x of nums pq dot push x while let's take while one. Okay, so now what do we want? We want these two elements. So uh, int 11 is equals to pq dot top. Now pq dot top. Okay, and la2 is equals to pq dot top. pq dot top Okay. Now, if both of these numbers are 11 greater than k and then 2 greater than k, in this case, what we do is we break. Also need an answer, and answer is equal to 0. So answer and we break. Or else we do answer plus plus and we add this value as to the array. So, so now like p q dot push min of the 1 comma the 2 into 2 plus max of the 1 comma. I should have just taken XML, but okay, that's also okay. Um, let's see if this will work. So this all is in the priority queue. It takes 1 and 2. Now, um, and it pushes uh, 2 plus 2, 4. It pushes 4. So it takes 4 and 3 now. Now it push 6 plus 2, 10. And uh, now we have 10, 10, 11. And after two operations, we'll have an answer. So I think this works. And we have an error, compilation error. Okay. Yeah, I thought there will be a problem here. I am not sure how to GREATM. Mm, mm. Ah, okay. Okay. So my answer comes out to be 3, which is an issue. Why does it come out to be 3? Um, okay, greater than equals to, so that would fix it. Okay. So what is the time complexity of this? Let's look at the time complexity and let's see if we can optimize it. So this is the very basic answer that I have. The time complexity of this. How many times can it run? So I know the time complexity of this will be log. So n log n is this. This is n log n. And the time complexity of this will be log n. Now, what? Hmm. So at max, so we take 2, insert 1. Um, so at max, it will be n square operations, n square log n. N square log n should be, mm, I think, but that does not make sense. N log n or n square log n. Let's take let's take an example. So sorry there. Let's take we have 1 comma 1 comma 1 comma 1 comma 1. Okay. And we take out two ones and we insert 3. So yes, which will give us 3. We take out two ones and we add 3 to it. Let's say there was also one more one. So this also becomes three. So uh, there were six values earlier. Now there are three values. So six plus uh, now three plus three. So six plus three plus six. Let's say there were 12 values. Let's say there were 12 values. So one comma one comma one comma one comma one comma one comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Earlier that so for these 12, six operations will be needed. Six operations are needed. All of this will convert into um, 3, comma 3, comma 3, comma 3, comma 3, comma 3. Okay. For these three operations will be needed. So yes, 3, and all of these will be converted into uh, 3 plus 3 is uh, so it's 3 into 2 plus 3, 9, 9, comma 9, comma 9. Okay. I should have taken something that is a multiple of 3. That is just, yeah. So it's logarithmic. So it's logarithmic. So um, log n into log n, I think. And now for this, two operations will be needed. So plus 2. So this will be converted into 18 plus 27 is 7. Uh, let's say 9 was our answer. Or like, yeah, if I would have taken. So yeah, basically we are getting log n into log n. So log n square is the time complexity. But n log n is greater than log n square. So I think that will do the overall time complexity. And this should work. Ah, okay. I did not look at the nums of I could be greater than. Okay, so I think this we can go for long, long. Let's try long and um, hmm. How can I fix this long? Yep. We can remove this. Yep. This works, but not a very uh, fast solution. Uh, and login, yeah, and login from here because this is login square. So this is greater than complexity. I think we can improve the space by making it longer. We don't need long line because integer plus time is mm, somewhat better. I think we need to improve. If there is a way to improve this, I would like to find it. Um, let's say that. Can we go? How much time did it take? Took me 16 minutes to explain this and write it out. Not a bad time. Um, okay. Long. Means and one, let two. Is there an another way to do this? Can I think of something that can make it better? Heaps are not a very like predictable. So I understand that the time complexity varies time to time. But instead of priority queue, if I take a set, will that help me? No, I don't think it will. At last, sets are order sets are also implemented using priority queue. So I don't think I can find another way to and a way to optimize this because I can't optimize this because I have to add it to the priority queue. Uh, can we do this? I want to check it out. Norms, begin, norms, and I just want to check it out. Obviously, it does not uh, change the time complexity, but memory wise, did it actually get better, or it's a one time fluke? It's actually got better memory wise, much better. Like, uh, right. Okay, so that helps. Uh, so one thing we can do is one small hack that I can think would could increase our time complexity somewhat better is we store this long or could actually also harm us if we store this and if uh, a is equals a smaller than k, then only we push a into it. So that reduces one login operation and changes it to multiple n operations. So let's just see. Ah, yes, what? No, PQ dot name PQR. Why is this a problem? How will this work? This answer will be greater than what answer we want, so this will not go into this. Will have 999. Yeah, I understand why. We can do somewhat like this, but I don't think like going into that way will much be a very useful. I think this is the best I can do. Yeah, 21 minutes, it's okay. Uh, Not bad, 7190. Normally wise, we have done very good with this very C++ thing. Now, approach one, yeah, priority queue. Uh, exactly like mine, exactly the same operation. Yes. Okay, so this is the only approach it has. Um, I think we can optimize it somewhat by finding a way where we don't have to add. Let's, let's look at some solutions. 100%. Yeah, question answer. Um, what does he do? Yeah, see, he is doing something like that. Then only we add. Okay, which is this is interesting. What is Y7? But let's see. I want to see a C++ version of this. Uh, yeah, this is exactly. This is what they are. This is the while issue that they are doing, which makes the answer better than 100. I think that's it. I can end this